Do you want to stream real-time video from your webcam or CCTV camera and even control your robot from anywhere in the world? Then buckle up, because we are going to build that from the scratch using Python, WebRTC and little bit magic of open source. So without further ado, let's get started and see how we can capture the video from these three different sources. Okay, so the first thing first, we will need to install this dependency on our local computer. Our local computer can be our Raspberry Pi and even our computer, basically anything that can support and run the Python script. So this Python dependency I have already created inside the install_dependencies.sh file. So let's just run it. Hit enter. Let it install and I'll see you at the other side. Once the dependencies are installed, you can hit cd/our local environment. So now we are going to write the Python script inside the Raspberry Pi to capture the video from webcam. So let's get started. Let's create a file name called sendWebcamStreamToServer.py. Hit enter. You can paste this script from the video description that I have attached, and don't worry about the explanation. I'm going to just open my editor and explain every single bit in detail. Press Ctrl O, enter to save the script. I have opened my code editor, and here you can see that I have created a detailed commenting for each and every line to define the purpose that why this line is here. So let's go through this script and see what's going on here. Here basically we are importing every dependency that is required to run the script. For example, capturing video from camera and sending it to the server using WebRTC. Here are some static configuration where we define the frame width, frame height and the camera index. If you are using multiple cameras in your local computer or Raspberry Pi, then change this index from 0 to 1 or 2 or 3 depending on your camera index. Here you need to do some server settings. Replace your server IP address with this text. These two lines only comes into the picture once we successfully install the MediaMTX inside our server, which is not done yet. So you can ignore this line for now. Here we are trying to open the webcam using the camera index. The library we are using here is CV2. If our CV2 library found the camera index, then we are defining the frame width and height. Here I just want to mention that I have used the lower resolution to keep my CPU uses minimum as possible. Once the RGB frame and timestamps are added, we are returning the video frames. These video frames are like 25 or 30 in 1 second. If you want to see each frame being captured, then uncomment this line and you will be able to see it inside your console. Now the interesting part comes here, because here in this step we are trying to establish a connection with our MediaMTX server using the Google free Stun server. Now I want to show you the diagram that how it's work. So here the offer sounds like, hey Google, I have an offer for this server. Whenever this server comes to your door, can you please let him know that I have an offer for him? And then when the server requests to the Google and check if any offer is available for this server, then server and our local computer establish a peer-to-peer connection. Once this connection is established, they bypass this Google server and directly communicate with each other. Now it's time to install the MediaMTX library on our server. As you can see, I am inside my server. Let's go to our root directory and create the folder name called MediaMTX. Now we need to find this MediaMTX library. You can just Google it and open the first link of the GitHub. Scroll all the way down and click on the releases. I'm using the Linux, that's why I'm finding for Linux. Here, this is the one for me. Copy link address. Now go back to your console. Now you can go inside the MediaMTX folder and type wget and paste the link that you have just copied. Now we need to unzip it To unzip it, type tar xvzf and then the name of the library, and you will get three files: license, MediaMTX YML, and MediaMTX itself. Now we only need to modify the MediaMTX.yml. So type nano MediaMTX.yml and open it. Here we only need to make two changes. So scroll all the way down first. The first change is here. We need to define the endpoint, which is in this case it's cam1, and the source as a publisher. If you remember, we are using the same endpoint name in our script as well. This endpoint name you are free to edit with anything you want, but for now I'll just stick with the cam1. Now apart from this path, we need to do one more setting. So scroll up and stop where you see the WebRTC. Here you can see the WebRTC ICE server 2. We just need to uncomment this line. This is a free Google server that helps us establishing a WebRTC connection between server and our local computer. Don't forget to remove this array. There is one space, so I'm going to remove it. Yes, now it's aligned. Now our server is ready to start. To start this server, type /mediamtx and hit enter. Make sure that your server port number 8889 is open. Now we can go back to our local computer or our Raspberry Pi and hit the Python script that we have created for the webcam. We are inside our Raspberry Pi terminal, and here if your local environment is not activate, then active it by typing source bin/activate. Now it's time to run our script. Python send webcam and hit enter. Now you can see that the WebRTC connection has been successfully established with the MediaMTX, and also on the server side you can see the log that the peer connection has been established from this IP address. Now it's moment of truth. Type your server IP address in the browser and enter 8889 port number /cam1, which is our endpoint. Boom. You can see the visuals on your screen, and this video is streaming using the WebRTC protocol. That means lowest possible latency. I just want to give you one example by counting 1 to 5. 1, 2, 3, 4 and 5. Congratulations, now you are doing your own broadcasting. Now for those who also want to see the output of CCTV camera, I'm going to quickly show you the script and then we are going to run it. So let's just go into our editor. Similar to the webcam, I have also created a send CCTV stream to server.py and also send Pi camera stream to server. So basically I have created all three different types of working script which you can use for webcam, Pi camera or CCTV camera. But for the sake of this video, to keep the minimum as possible, in this video we are now only going to cover the CCTV stream. So let me just give you some overview. In the previous script of webcam, we are trying to get the video from webcam and then processing it, but here we are directly getting the ready-made video using rtsp protocol. If your camera is supporting rtsp or on-web protocol, then you need to enable it. Once you will enable it, you will get the username, you will get the password, and usually the rtsp port number is 554. You can check with your camera provider on their websites. We are also getting stream 1 and stream 2. Stream 1 is for the high quality, stream 2 is the low quality. Here the camera IP, mine is ending at 111. Your can be different, which you can again find from your router setting or your camera application. Those are the only changes in this script. So let's just create this file on our Raspberry Pi and run it. Python send CCTV stream to server, hit enter. We have again established a successful connection. Now let's go to our browser and boom, we are again live. Now this stream is coming from our CCTV camera. If you have the CCTV camera application installed, now you can rotate your camera. See, it's moving. You can go up just like this, down. Now for those who are also interested in my robot project, we are going to use this CCTV camera, the same CCTV camera in our robot, and control the movement and get the live stream on our mobile or on our laptop. So if you are interested in that project, please hit that subscribe button and be the part of this journey of innovation. Thank you for watching and see you in the next video. The next video is going to be really interesting because in the next video we are going to create our custom layout and control the camera movements using the WebSocket programming.